Good evening, my name is Suraj. I am a GSI for Data 8 this fall, and today we will be reviewing some concepts regarding histograms. Okay, and so this is in preparation for midterm 1 in fall 2017. Okay, so today we'll be going over a practice histogram problem, but before we get to that, I wanted to review some concepts with regards to histograms. So here we have some review points created by Fahad, one of our head GSIs. So let's take a look at what some of this is saying. Okay, so the first thing that you need to know about histograms is that the area of each bar represents the proportion of the total population that is found in that specific area. And what exactly does that mean? Well, let's consider this bar, for example, right here, where on the x-axis it seems like it goes from 10 to 30. Okay, so what this first rule is saying is that if I were to find the area of this bar, it would tell me the proportion of values, so a proportion is between 0 and 1, it would tell me the proportion of values in the entire histogram, or in the entire population, that fall between 10 and 30. And similarly, if I were to find the area of this bar that goes from 70 to 80, it would tell me the proportion, or the fraction of values that are between 70 and 80 in this entire population. Okay, and so how do we calculate area? Well, it's the same way we calculate area in regular geometry. So the area of each of these bars is equal to the width of the bar times the height of the bar. Okay, so in this example, if we wanted to find the area of this rectangle or of this bar, the width would be 30 minus 10, and the units are whatever the units of the x-axis or of the values are. So they can be inches, centimeters. In this case, we have a histogram of grades, so they're in percentage points. So here we would have our area is 30 minus 10 percentage points. Okay, and then our height. Well, so now this is where there's an interesting point of clarification with regards to the height of histograms, right? Well, so here it seems like the height is around 0.5. It's actually 0.45. But what's the unit? Well, we know that the area has to be in proportion, which is some fraction between 0 and 1. Or, as this last point says, the areas could be in percentages, right? Which means it's the proportions times 100%, right? But the heights don't have units attached to them. Or sorry, take that back. The areas don't have units attached to them, right? So for example, we want the area of this bar to be something like 0.3 or 10% or something like that. Those have no units attached to them. They're just numbers, which tell you the fraction of values that fall inside the range, 10 to 30, right? So what units do we have to make our height have so that the area has no units? Well, it turns out, since area is equal to width times height, the units that the height must have is proportion per whatever is on the x-axis, right? And it says that right here. Proportion per unit of x-axis. So we could have, proportion per percentage point, right? And then you can see here that it clearly doesn't have proportion per percentage point. It actually has percent per percentage point. And that's what it's talking about here, where for the height scale in a histogram, you could either use proportion or you could use percentages. And the difference is that percentages are equal to proportions times 100%. And 100% is simply 1, because percent just means per 100, right? So the y-axis, or the heights of the bars and histograms, are either proportions or percentages, right? And you should be able to tell, based off of the information you're given, whether you're dealing with percentages or proportions. And here, so we're given that we're dealing with percentages, the corresponding proportions would just be these percentage values divided by 100. So instead of 2, we'd have 0.02. Instead of 1.5, we'd have 0.015, and so on and so forth. So if these were what our height values look like, then we'd be dealing with proportion. But in our case, we're actually dealing with percentage. And so what happens to be the area of this red bar right here? Well, it's 20 times 0.45 percentage per percentage points. So it's 20 times 45%. because the percentage points and per percentage points cancel out. And whatever that value is, it's slightly, I think it's 9%. That's telling us that 9% of all of the values in the population are between 10 and 30. And so if this is a histogram of students' grades, it's telling us that 9% of students got a grade between 10 and 30. So hopefully that's clear. Okay, so now we're going to take a look at a practice histogram problem, one that may be similar to the one that you'll find on your midterm. So we're given the same histogram as before. We're told that it contains the grades of some students, and that this table is called student info, and all the grades are between 0 and 100. Okay? And we're given the bins and their respective heights. So part A asks us, what range contains more students? The 30 to 50 bin or the 50 to 60 bin? So what grade range did more students fall into? 30 to 50 or 50 to 60? And so to calculate this, we just need to remember the fact that in histograms, areas of bars correspond to proportions of values that fall into those bins, right? So if we find the area of the 30 to 50 bar and of the 50 to 60 bar and compare them, we'll have our answer. Right, so first let's look at the area. Ooh, that's kind of messy. The area of the 30 to 50 bar. Okay? And we know that the area is equal to the width of the bar times the height of the bar. Here, in our case, our width is 50 minus 30 percentage points. And our height is, it tells us it's 1.2% per percentage points. Okay? So this is equal to 20 times 1.2% because the percentage point units cancel out. And what's 20 times 1.2%? That's 24%. Okay, so that's the area of the 30 to 50 bar. Now we need the area of the 50 to 60 bar. Area of 50 to 60. So now we have this, the width is the same. Well, not the same, but it's calculated the same way. 60 minus 50 percentage points times the height, which is 2.2% per percentage points. Percentage point units cancel out again, and we're left with 10 times 2.2%, which gives us 22%. And so now, what does this tell us? Well, it tells us that 24% of students had a grade that was between 30 and 50, and that 22% of students had a grade that was between 50 and 60. So clearly, there are more students in the 30 to 50 range. So that answers part A. Now we're actually almost done answering part B as well, because it's asking us what proportion of students had a grade between 30 and 70. Well, let's look at the bars that make up 30 and 70, right? So that gives, we need the 30 to 50 bar, the 50 to 60 bar, and the 60 to 70 bar. And if we had the areas of each of these bars, we'd be able to find the area of effectively the number of students that were between 30 and 70. So area and proportion are the same. We already found two of these three values, right? We know that, well, that 24% of the values are between 30 and 50, and that 22% are between 60 and 70. So now all we need to do is find the area of the 60 to 70 bar, and we're good to go. And so that calculation is the same. So the area of the 60 to 70 bar is equal to the width, 70 minus 60 percentage points, times the height, which we're given to be 1.8% per percentage points. And so that's 10 times 1.8%, which is 18%, which tells us that 18% of students had a grade that was between 60 and 70%. And so that allows us to fill this in, 18%. And so now the sum of those values, well, 22 plus 18, that's 40. 40 plus 24 is 64. So our final answer for part B is 64. So 64% of students had a grade that was between 30 and 70. Part C asks us, well, it gives us a rebinned version of the same data. So what they did from the NumPy side, or from the IPython side, was that they called the histogram function with a different set of bins. And before, the bins seem kind of arbitrary, 0 to 10, 10 to 30, and so on and so forth. But here they used np.arange to generate the bins 0, 125, and 25, which gives us the bins 0, 25, 50, 75, and 100, which is what we see here. So now they're asking us, can you find the values of A and B without any additional information? Why or why not? Well, so A and B are the heights of the 25 to 50 and the 75 to 100 bars, respectively. And if we were able to find these heights without any additional information, it would be because 25 to 50 or 75 to 100 would be the sum of multiple bars from our original histogram. But there are no 2 or 3 or any number of bars that exactly make up the 25 to 50 range, right? The bars we have in our original histogram are 0 to 10, 10 to 30, 30 to 50, and so on and so forth, right? And there's no combination of these that makes up 25 to 50 exactly. Because if there was, we could find the areas of those bars, and then the area of this new bar has to be the same. But for a 25 to 50 bar, some of the values will be in this bar, and the rest will all be here. But we don't know how many values are inside the 10 to 30 bin. And so that's one of the caveats of histograms. All you know is that, for example, in the 30 to 50 bin, that all you know is that 24% of the values are between 30 and 50. You don't know the distribution inside of 30 and 50. They could all be equal to exactly 30. They could all be equal to exactly 49. We don't know. And for that reason, you can't split a bar of a histogram into 2 other bars without looking at the original data. So there's no way to, rebin or to find these heights, of the 25 to 50 bar, the 75 to 100 bar without additional information. It's impossible because you can't split bars because you don't know how the values are distributed in the original bars. So that's why you can't do part C. But part D, though, you can. So what additional information does it give us? It tells us that the number of rows in the student info table is equal to 100. So it tells us that there's 100 students. And it also tells us that there are 46 rows where the values of the grades are between 75 and 100. So it's telling us 46 rows, or rather 46 grades, are in 75 to 100. And remember, R between includes the first element and excludes the last element, just as regular as Python does normally, right? So what this is telling us, it actually gives us the proportion of values that are in the last bar, because it's telling us number of values over total number of values, right? So the proportion of the 75 to 100 bar is equal to 0.46. So actually we can say the percentage is equal to 46%, because that's just 46 divided by 100. So we know that the area of the last bar has to be exactly 46%. So 46% is equal to the width times the height of this last bar. Well, the height is what we're solving for, so we can rearrange for that. So we can see the height is 46% divided by the width of this last bar, which is 100 minus 75 percentage points. And so now we need to find 46 over 25, which is 1.84. So that means B is 1.84. And so to recap how we solved this was the problem told us that there were 46 values in the last bar, in the last bin, and that there were 100 students in total. So by dividing 46 by 100, we got the proportion of values that were in the last bar. And since we're dealing with percentages, I multiplied 0.46 by 100 to get that there's 46% values, so that 46% of the values are in the last bar. And we know that the areas correspond to the proportions. So I can say that 46% is the width of the bar times the height of the bar. We know the width is 25 because we're given how wide the bar is, and so we solve for the height, which is 46 over 100 minus 75, which is 1.84. That was B. But how do we find A? Well, we can do it by asserting that the total area has to be what? The sum of all the areas in the histograms has to be exactly what? Well, it has to be exactly 100%, right? Remember from the slides earlier that the area of all the bars in the histograms in total must be either 1 or 100%, which are the same thing, right? And so if we know the areas of the other 3 bars, we can easily calculate the area of the bar that includes A. And if we know that bar's area, we can find the height because we know its width. So let's say the area, actually, let's write out the entire statement. So we know that 25 times 0.2, that's the area of the first bar, right? Plus 25 times A, plus 25 times 1.72, plus 25 times 1.84 has to be exactly what? 100%. Okay? So now that we have that, all we need to do is rearrange for A. And so let's go ahead and do that. Well, so we know that A, or 25 times A, is now 100 minus, well, it was 44% from the last question, or sorry, 46% from the last question, minus whatever 25 times 1.72 is, which happens to be 43%, minus whatever 25 times 0.2 is, which happens to be 5. So that means the proportion of values that fall into this last, into the bin for A is whatever this evaluates to be, which is 100 minus 46 minus 43 minus 5, which is exactly 6%. So we know that 6% of the values lie in between 25 and 50. Okay? And so now we need to find the height, which will just be A is equal to 6% divided by 25 percent points, which is equal to 6 divided by 25, which is 0.24% per percentage points. And so that's the value of A. So let's recap, because that was quite complicated. So we asserted that the total area of all of the bars in the histogram was exactly 100%, because you have to have all the values. And so we know that if we sum up all the values of all the areas of each of the individual bars, we should get 100%. And it turns out that we knew the areas of 3 of the 4 bars. We knew the area of the first bar, third bar, and we just calculated the area of the 4th bar. So if I subtract all of the other areas away from this left-hand side of the equation, I'll get that 25, which is the width of the A bar, times the height A, must be 100% minus the areas of all the other bars. So that's why we had 100 minus 46%, which was the area of the B bar, minus 43%, which was the area of this bar, minus 5%, which is the area of this bar. And 100 minus 46 minus 43 minus 5 was 6%. So that told me that 6% of the values were between 25 and 50. That was just the area though. I needed to find the height, which was the area divided by the width, which was 25 percentage points, which gave me that 0.24% per percentage points was the height of the A bar. So A was 0.24. And that just about concludes this video on histograms practice. If you have any questions, feel free to ask them on Piazza, and otherwise, good luck on your midterm.